Hi guys, today we are solving one of the most famous interview problem, sum, and this problem is most important because it teaches one of the most powerful interview concepts, hash maps. We have given an array of numbers and a target value. We need to return the indices of the two numbers whose sum equals to the target. For example, if you go with example 1 here, we have given an array of 2, 7, 11, 15 and the target is 9. We need to return the indices which the elements are equal. The sum of the elements is equal to 9. In this case, it is 2 and 7, right? If you add 2 and 7, it will be 9. So we are returning 0, 1. Is the basic understanding of this problem. So the important condition is we can't use the same element twice. So in the interview, we don't directly jump into the optimal solution, right? We start with the brute force approach. So we check here, if we start with the brute force approach, we can check with the pairs, every pair. For example, 2 with 7, 2 with 11, 2 with 15, as likewise 7 with 2, 7 with 11 and 7 with 15, so on. We can basically a nested loop. The code idea is for every I and every j, we need to check whether the number in the I plus number in the j is equal to the target. This works, but the problem is efficiency. If there are n numbers, for every numbers we might check almost all remaining numbers, so the time complexity will become big of n square and the space complexity will be constant. For smaller inputs it is okay, but if for huge inputs this becomes slower. So how can we improve this solution? Here I'm introducing a hash map. So how we can make search fast? This is where hash map comes in the picture, where hash maps basically stores the key value pair. Here in this problem we can take for 2 as a key and its index as a value. We can store the index and its corresponding element in the hash map. The biggest advantage of using this hash map is the complexity, search time complexity. The searching inside the hash map is almost of a constant time, big of 1, means instant lookups. The core idea is, instead of searching for the second number manually, what if we directly calculate the number we need? For example, we are at the 7 when the pointer is at the 7 and we know that the target element is 9, though. So the question becomes is, we already seen this 2 that we want, so that we can get the target element 9. How we are getting this 2? Basically you are minusing this 9 with the 7, means if you reduce the element from the target, you will get the element that you need to get the target element, right? So you can search in this way. When you got the 2 and if you find this element is in the hash map, basically in the hash map you are storing that key and its corresponding indices, right? Once you know the key, then you can return the index from this hash map. So the optimal approach, now the algorithm becomes simpler. Loop through array, find the complement is basically target minus the current number, and check if complement exists in the hash map, and if yes, return that answer. If no, we store that current number and its corresponding index in the hash map. This is the flow that we need to follow to solve this problem. The important details is that important detail that we need to concentrate is always check first then insert. You can ask why it is, because we cannot use the same element twice. That is a very common interview mistake. They have mentioned that exactly one solution and we can only use the same element once, not the twice. So if you dry run this code, if you are at the 2, means I is at the 0, so the complement will be 9 minus 2, that is 7. In the hash map, we will look that if does 7 exist in the map. No, then we store this 2 and its index in the map, means key will be 2 and the value will be 0. Next we will move to the 7 and its complement. What will be the complement? 9 minus 7, it will be 2, and we will check whether this 2 already exists in the hash map. Yes, it exists. In the previous iteration we have added that in the hash map, right? So we know the key is 2 and its corresponding index is 0. So we return that 0 and we know that we are at the I, means we are at the 7. So we know the first index value and second element value, sorry, and we will return that indices based on this condition. So the complexity, each lookup is O of n, right? To reading the you have key and you are reading the corresponding index from the hash map, so the lookup will be constant time O of 1, and the traversing array is once, so the time complexity will become O of n, and the space complexity also becomes O of n. As you can see, there is a huge improvement from our brute force approach. That in the brute force approach we are getting over O of n square, but here we are solving this problem in O of n. That's a biggest improvement, right? So the key takeaway is, what will be the pattern recognition in this problem? This problem teaches a very important interview pattern. Whenever interview asks us find 2 value quickly, we should look into the hash map lookup. That is the key pattern, hash map lookup. And the similar kind of problems we can solve in 2sum as, or contains duplicates, subarray, etc. These are the problems that uses the hash map that we need to keep in mind. We can see this problem. I have solved this one. Here, see, I have defined and hash map. Here, as I mentioned, I am iterating over the hash map here first, right? Once I am iterating over it, I am finding on for the each element, this one. When I am at the 2, I am checking here, checking is target is 9 minus 2. 9 minus 2 is equal to complement will be 9 minus 2 is 7. So does this 7 contains in the hash map? No, right? It is the first element. So we will add it, we will put that in the hash map. In the next, the I will become 1. So number of 1 will be 7. So target minus 7 means 9 minus 7, right? 9 minus 7 is 2. Does 2 is already in the map, means in the set? Yes, it is already in the map. So we will get that element and its index by using the get method, and we already know that we are at the 7, right? We are at the 7. We know the indices of this 7, which is I. We will return that function and we will exit. I mean, basically when you find the target, you will directly exit. If you don't find any of the solution which is not in this array, which is not equal to target, finally it will return -1 comma -1. This is the basic and optimal solution that you can use to solve this problem. Let me run this. If you run this one, yeah, you can see this. Yeah. If this explanation helped, please you can see my other videos also. Thank you.